All right, today we're going to look at what we are going to call similar figures, and we're going to look at some attributes of those similar figures. So attributes are kind of like just like characteristics or what qualifies for them to be similar figures. So there are two main things that we need to know about similar figures. First off, corresponding sides are going to be proportional. So proportions, remember, are two equivalent ratios. And we've been talking about proportions when we've used that one table, words, original ratio, and new ratio. So corresponding, in case you're not sure, corresponding sides are going to be side lengths that are going to be in the same relative place on two or more figures. So once we look at these pictures today, we'll see what that is. Now the second qualification for it in order to be a similar figure is that the corresponding angles are going to be congruent or equal to one another. So there's a couple things that we can tell with this. So first and foremost, if we have a problem that tell us the two figures below are similar, that means that we can solve for their side lengths using proportions. If they also tell us that the two figures are similar, that means that their corresponding angles, so the angles in the same relative position on both of those figures or more, are going to be equal to one another. Now sometimes they'll give us pictures and ask you, are they proportional? So just depending on the situation, you're going to have to solve it. So these are the two main facts that we need to make sure that we know for similar figures. So for example, if we have a three-sided figure, not only does it have to be, that doesn't necessarily mean it's triangle because the inside angles have to be 180 degrees, but if their corresponding angles are not congruent, even though they both look like triangles, that means they're not going to be proportional. They're not going to be similar figures. If we were working this out and their ratios were not equivalent, so their two ratios were not equivalent, that means they're not proportional. So just because the sizes of the shape or the shape themselves look like they are both triangles or rectangles or trapezoids or whatever it is, this is how we have to prove it. So we'll be working with that today and the next couple of lessons as well. So let's first of all we're going to look at today is just identifying those corresponding sides and corresponding angles. So if we have a problem that tells us. So we're going to assume that these two triangles are corresponding. So if they are corresponding, the corresponding angles. I got ahead of myself, excuse me. So we're going to assume that these two figures are similar. So all we're going to do is we are going to color the corresponding angles that match up, okay? So what that means first is we need these triangles in the same position. So if they're not turned the same way, I'm going to show you a couple ways how we do that. So right here, angle A in this bigger triangle is 30 degrees. And in the same relative position right here is angle D. So angle A is going to be congruent or equal to angle D. So angle D is also 30 degrees because these are in the same corresponding, the same relative position on each of their triangles. Then down here, angle B is in the same position as angle E. So this, I'm going to use the same color they use over here. So angle E is 40 degrees. So angle B is corresponding with angle E, and therefore they are congruent in measurement. They're equal to each other. And then this last one, we have angle C, and on here it's yellow, but if I use yellow on the paper, it's going to be kind of hard to see. So I'm going to use orange, is in the same relative position as angle F. So angle C is congruent to angle F because they are corresponding angles. So that means the measurement of angle F is 110 degrees. So once we know that these figures are similar, we would be prepared to answer any questions on these angle measurements of this other triangle. And I do know that this is a triangle because 30 plus 40 is 70. 70 plus 110 is 180. Just to remember that triangles have to add up to be exactly 180 degrees. Okay, so let's look at what happens when the triangles are not facing the same position. So there's a couple of ways that we want to go around about this, okay? First of all, this triangle is smaller than this triangle. So we need to visualize if we were to rotate and draw the smaller figure inside the bigger figure, okay? So if we were to rotate this around, you can flip it, you can reverse it, you can turn it, anything that you can visualize. So if you see this right angle right here, and their right angle is right here, and also your smallest side is going to, on this triangle, is going to go with your smallest side over here, okay? So that's another thing that we can kind of think of. So what we're going to do is if you were to visualize drawing this around, you can see that this 8 compared to this 6 with this right angle, well, this 52, does that look like where the 6 is or where the 8 is? And hopefully you said the 8. So I'm going to draw that right there. I'm going to draw this right here. And the side length across from that right angle is that yellow or that orange that we're going to use. So basically we turned this smaller triangle around for those measurements, okay? So the red 52 goes with this measurement of 8. The blue right here goes with this measurement of B. So we could figure out what B was. And then the side across from that right angle right here was 10. So we have our right angle right there, okay? So all we're going to do right now is just identify their corresponding sides. So 8 corresponds with 52, 10 corresponds with 65, and 6 corresponds with B. In our lessons later on, we're actually going to set up proportions and solve for that missing length, okay? So here again, here's the smaller triangle to this larger triangle. So if we were to fold this inside and draw that smaller shape inside, we could actually see, so if you kind of visualize it like this, I'm going to do like a dotted line, that would be this part right here. Okay? So when we do it like that, line segments, you draw a line, and then you just put the letters below it. So Y, X is going to be, corresponds with line segment AB or BA. It doesn't really matter how you say it, either way. Okay? So this side length is proportional to this one. But if you guys see that you only see one purple line, well, look at that bigger triangle. That actually means that BC, line segment BC, corresponds. So it doesn't look like 2 purple lines because they just overlap, corresponds with line segment YC. And again, all we're going to do today is identify the corresponding sides or the corresponding angles, and then later on we'll actually solve for those missing pieces. Okay, we're just color coding those corresponding sides and angles. So if the triangles or the shapes or whatever they are not in the same position, good idea, think about taking this smaller triangle and putting into that bigger triangle, and it will help you to see those corresponding angles and sides. Or folding this over just like we did, we visualize this little triangle in the same position as this one. Okay, let's get a couple more done. All right, so we have 2 quadrilaterals down here. Remember, quadrilaterals are 4-sided figures, and this looks like it's going to be, or it could just be a polygon, but we'll get more into that later on. So let's look at this 4-sided figure, okay? So this is 6 inches. We don't know the side length right here, and then this one is letter N. So I'm going to use this one. I'll just color this one over. We'll just do this in red, okay? And then we can also do this one. We'll just use all 4 sides. We'll do this one in orange. All right, so we need to visualize taking this smaller 4-sided figure and putting it inside here. So if you look, this 6 inches, even though we don't know what this green side is, you can visually see that this is a little bit taller. And so if you look right here, this isn't that much taller, but this side is. Okay, so we're going to visualize reversing this and drawing it inside there. So if we reverse this, the 6 inches would be here, going with that, we're going to color this 12 inches. So those are in the same relative position. Again, if we reverse this, then the green ST is going to go with the YZ over here. So I'll color this green. Okay. Now we didn't turn this one around like we did this triangle here. So you can see that this just is going to flip over. So RS is going to be corresponding with XY or YX. When you do line segments, it doesn't matter which letter you say first. And then QT or TQ is going to correspond, because we reverse it like that, with this ZW or WZ. So that color I used was red. So I'll just draw this over here. Okay. And then this was letter N for this one. I'm just going to put it inside my shape. So we can make a prediction right now. If these are proportional sides, we actually have a scale factor from 6 to 12. I can do times 2. Or a factor of change from 12 to 6, I can divide by 2. So if I'm going from 12 to 6 by dividing by 2 and corresponding sides are proportional, well, 24 divided by 2 is 12. So that's how we can solve these. And we'll do that more later on, but just to kind of give you a heads up. So we actually know that the length of N in this smaller shape would be representative of 12 inches. Just to see that's what's coming up. All right, let's look at one more, and then you're going to have some practice. Again, all we're doing is identifying the corresponding angles or sides. So for example, this angle, whatever measurement would actually be equal to that one, because they are corresponding angles in the same position. Oh, let me label this too, by the way. This was RQ, and then this one, because we reversed them, ST. So we could actually see that angle T corresponds with angle Z, so those would have the same angle measurements once we knew what they were. Angle Q corresponds with angle W, so those would be the same measurement. But if we didn't reverse that and draw that smaller side in the bigger figure, we might think that angle T was corresponding with angle W, and it actually isn't. So that's why we want you to draw these out and visualize that. All right, so we have triangle ABC, and it's similar to this triangle, but they are not facing in the same position like this one is. So we need to go ahead and imagine drawing this triangle inside here. The first thing I like to do is I like to see what's across my right angle, which is this 50, and what's across this right angle is that X. So I actually know that those two angles, or excuse me, those two side lengths are corresponding, okay? Now think about it this way. They give you this 20 and an unknown. So do you think that when I turn like this, is the 20 going to go with this red? Well, no, because that means that right angle would be up here. So we're actually going to rotate it again. So that means that this side length 20 is going to go down here with that 40. Okay, so again, just kind of visualizing taking this triangle and rotating it until you can see that the right angle is going to be right here. Okay, and here again, that right angle is across from that X, okay, or that X is across from the right angle. Then if we rotated this unknown goes with this unknown, okay, which is AC. So this side length was, we'll just use purple to label it. We had X, Z, so angle Z right here, and then angle Y right here, and you can see YX right here, ZY, which is right there, and so on. So we can color code that. So CB corresponds with YZ, AC corresponds with XZ or ZX, and then XY right here corresponds with this AB. Okay, so now we actually know every single side length that corresponds to what side length in this one. We could also go a step further and say the angles that correspond. So now that angle Z corresponds with angle C, and again, we know that they're congruent Those are your 90 degrees, those right angles. Angle X corresponds with angle A, and angle Y corresponds with angle B. So once we knew what angle Y was, we actually know what angle B is because of these two attributes, these properties of similar figures. All right, again, if you need to rewatch this video just to kind of hear it again, please go ahead and do that. And of course, let us know if you need any help.